So this is the first part of how to characterize objects and their spectral behavior. We will close this and have a look on the two other possibilities of using this profile tool. So we have the spatial profile. This is orientated along a profile which you can create with these polyline, and you will only draw a polyline through your area you are interested in, and you will see the spectral behavior. So we have a small decline in the first bands, and you have to select your bands over here. But yeah, maybe this polyline wasn't that interesting, so let's go to another area. Therefore, once again, open a new, select this, make a new polyline, and this is straight through the forest. So we will have a second profile, and as you can see, there's some undulating behavior here, but this is due to maybe some kind of problems in the sensor, or maybe on a different way of how, or a different percentage of trees covering the ground, and you will have that undulating behavior in the first three bands. In the fourth bands you will have some major differences in the spectral reflectance, and also in the fifth band there's much more amplitude here in the or variance maybe in the values, and in the sixth band it's quite the same like in the first three bands. So this is the second way of having some information about your object, and the third way is to make a surface out of it. Therefore you will just create a rectangle in your area like this over here. Let's take this, and this rectangle is now represented in its reflectance in the special bands. So you have the band 1, you can see this whitish object over here, which is probably some kind of big house or anything else. You will have, or it is reflected over here, and you can just go through that, and you can see it's really good to see here in the third band, and in the fourth band no information at all. So you just have undulating feature over here, so it's nearly quite stable in the fourth band in its reflectance. Fifth band, totally different point of view, and sixth band as well. But let us now once again have a view on the spectral profile of special objects. So there as some kind of example, for the k-means algorithm, I would like to show you the spectral profile of a forest, which you can see here now. So I think this will fit our needs. So it's now 7 graphs you can see here, all are representing forest. So this is dark green, apply, close. And as a second object I would like to show you water. Once again, I've shown you beforehand, I know, but I will now do it once again. So, and maybe another lake, this really dark lake over here, and I will show you that in the color of blue. So as you can see here, you will have the differences in the amplitude here is about 40 units in the fourth band, and in the fifth band about 30 units. And having this in mind, I would like to show you how to differentiate between these two objects. And this is a water object and this is a forest object, in my words, using only the information in the third and the fourth band. Therefore I will now switch over to PowerPoint and show you that in PowerPoint. Using some pixel out of water and some pixels out of forest, and please keep in mind that this value is about 35 in the third band, so no real difference between these two physical bodies, and you will find a digital number of about 20 in the fourth band for water and 60 for forest. So keeping that in mind, we will just flip over to that chart. So we will print the values of the band number 3 against the values of the band number 4. And looking back at this, in the band number 3, both bodies have the same reflectance of about the digital number 35. So we will have here water and here a pixel with forest. And yeah, we will not only concentrate on one pixel, we will concentrate on a lot of more pixels. So about 50 pixels over here, 50 pixels over here. So what is now done, the computer tries to separate these two bodies into classes. Therefore, he will use an iterative way. So in the first iteration, he will just search for, or he will just use two centers or two centroids. So this is over here and there's the center over here, and he is now trying to make a solution of a classification using two classes. And this is special on the k-means. So for k-means you will need a number or a given number of classes, and for this it's obviously there are two classes of bodies, water and forest. So in the first step, he will, or the PC is segmentating this kind of graph over here. So we will have one class over here, one class over there, and so as you can see, only 10% maybe of all the pixels are belonging to the class number 1 and 90% of the pixels belonging to the class number 2. So in the next step he will compute the centroids of these classes. So the new centroids of these classes are here. So it's about not 50% over here, there are 40% over here. So this is one centroid, and another centroid is among these pixels. So once again, we will try to segmentate this graph into two sides, this side and the second side, and we will find a quite good solution because all the water pixels are on one side of this line and all the forest pixels are on the other side of the line. But as you can see, the centroid of this class is way out of the forest area. So once again, we will compute another solution. The centroid is now in the middle of all the pixels from forest, and here the same, the centroid of this class is again in the middle of the pixels of water. And now we are finished with this quite simple example, just by concentrating on two classes using only forest and water. Now you have to think about using not only a two-dimensional space like the band number 4 and band number 3, but using a six-dimensional space and with much more interaction between these pixel classes. So you will not only won't find any gaps between this. So you're trying to segmentate these this space into a certain number of classes.